Good afternoon, everyone. Thank you all for coming to the panel on teaching Scala. We're really excited to be here today. Just to give you a quick overview of what we're going to be doing this afternoon, we're all going to introduce ourselves as the panelists. I'm going to have some moderator-led questions for about the first 30 minutes of the panel, and then we'll open it up to all of your questions for about the last 15 minutes of the panel. So I will be guiding the first part of the session. The panelists are aware that I might be interrupting them, so I've already warned them about that. You don't have to think I'm being mean. But as we're talking, if you have any questions that you want to ask, be thinking about those. And of course, we'll all be around throughout the rest of the day and hopefully the rest of the conference if our questions don't get answered in the 45 minutes that we have here. So once again, thank you for coming. My name's Kelly. I am a Scala developer and currently a developer evangelist at Twilio. My experience with Scala is mostly in data engineering, and I have experience teaching Scala through the Scala Bridge program, which is a education outreach to female and underrepresented developers that might know another programming language, but don't necessarily know Scala. I'm going to pass it on to the rest of the panelists now to introduce themselves. One last thing, I wanted to thank Ryan for really wrangling us today to get us here on this panel, so it wouldn't have happened without him. And take it away, Neville.
All right. Hello, everybody. My name is Neville. I work at a company called Spotify. I've been using Scala for maybe 3 to 4 years, mainly on data processing. And in the last couple of years, I've been pushing for adoption for Scala as a main language for data processing at Spotify. And we've grown from like maybe 20 people to, at this moment, more than 300 engineers writing data pipelines in Scala.
Hi, everyone. My name is Maciek. I work here in Berlin in Wire. We do end-to-end encrypted messenger. And I work as a Scala developer doing the Android client for Wire. So we started as a project mainly in Java, as an Android project, but now we mostly migrated to Scala. So I'd like to say something about it. Also, I'm trying to show that Scala is great for mobile applications.
Hello, my name is Ryan Tanner. I work for Twitter in our Colorado office in Boulder. I started using Scala about 8 years ago, and at Twitter, I teach a couple of courses on the Scala Collections library. I'm also currently spearheading a new onboarding effort for new hires to help get them up to speed on Scala and on the Twitter stack, so I'll be speaking about that today.
Hello, I'm Martin Redeski. I design Scala, and I'm teaching it in I'm teaching it in second year with 2 courses. One you probably all know with the Principles of Functional Programming in Scala, which is a MOOC, and the other one on concurrency and parallelism with Heather as one of the co-teachers. I have a lot of experience in teaching it in a university setting, and when I started TypeSafe and now Lightbend, we also developed a lot of course materials for industry. So I know some of that as well.
And I'm Heather Miller. I co-founded the Scala Center with this one. I also did my PhD under this one. So I have, I don't know, since 2011 or 2010 or so, I've been using Scala. And I've participated in sort of developing several of these MOOCs. So the functional programming MOOC that's about programming with Spark. And I'm also a professor, and I use actually Scala for a bunch of these courses that right now I'm teaching a course on, or I just finished teaching a course on big data processing or whatever, and of course we use Scala for that.
Awesome. So our first question is going to be for Heather, Maciek, and Neville. How do you help newcomers understand Scala isms, or things that are specific to the Scala programming languages? And that's newcomers, whether they're new to programming or new to just Scala. Heather, why don't we start with you?
Okay. So actually, I don't have, my solution is maybe not the best solution, but I like to provide examples first to people, and then when they see how something works, then I start using the terminology to explain the pieces. So I take very much an examples first, and then jargon next approach. And depending on where those people come from, if they have already learned a little bit of functional programming in Haskell or in like Racket or some other programming language, I then try to relate that terminology to one of those languages as well. Because some of these terminologies, they mean the same thing, they're slightly different.
Maciek?
Okay, so Wire is not a very big company, so we don't have like an official teaching curve. But in time, we developed simply like two main approaches: that we need a friendly environment, which is probably the same as in every language, and also we give a newcomer time and opportunities to experiment. So because it's quite unusual to find people who are both Scala and Android developers, we usually get just someone who is expert in one of them, and we try to teach the other. And in that case, I think Scala is in a good way that it's a good idea that Scala is like a mixed language. So even if someone already knows Java and writes Android in Java, then looking at our code in Scala, it's still quite similar. So we can just leave that person with our project, which is quite big, and it's written in sometimes parts of it are more functional, some parts of it more object-oriented, but still it's well written, so we can simply trust that person that she or he will just be able to find out her way around it. And because it's an Android application, so it's easy also to check what the effects of the experiment do. So like you can always compile it and just see what you broke. And so yeah, it also scales well, because this way we can just leave that person with the project. If the environment is friendly, and that means that that person is able to simply ask anyone and just borrow the time of another developer. And even if there are simple or silly questions, then that person will know that they will be answered. Then that's okay. So a drawback is probably that we would be faster if everyone just focused on the task at hand and then switched to another task. But this way, we can be pretty sure that in time, that person will become will not be afraid of our code, will better understand the project and so on. Yeah, that's basically what I wanted to say.
Cool. Neville?
So most of our Scala users are from a data science machine learning background, so like R or Python. So it seems to me the hardest part is to teach the idea of a pure functional immutable data, concept of applying functional transform, and how they map to, let's say, distributed system MapReduce paradigms. So we basically ditch majority of the OOP type safety part, like nothing about traits, classes, variances, anything like that, and just focus on like playing with the collection library, applying lambdas, and then gradually introduce, let's say, something like Spark, and we have our own Scala API for Google Cloud, and then we teach how the collection and combinator idea apply to map size reduce, or even later introduce concepts like semi-group and monoid, essential to parallel data processing. So that's our take.
Excellent. My next question is for Ryan, and this is on Twitter specifically. And so Twitter has a very extensive internal training program. You told me that Twitter has probably had over 5,000 Scala engineers.
Lower than that.
Okay. Many thousand Scala engineers over the course of its existence. And can you share what works about your internal training program for Scala and how other companies could benefit from the stuff that you've built?
Sure. So I want to first give credit to the Twitter University team. They're not here, but they run the program. I'm not on that team. And they're a team of 3 fantastic instructors, out in San Francisco. And they have the unenviable task of training every engineer who comes into Twitter. Every engineer spends a week in San Francisco at what we call flight school, coming up to speed on Scala, as well as Twitter Stack, Finagle, Finatra, and so on. So that's one tactic that we use to train engineers who come into Twitter. We have several others. After that program, we have a suite of courses that engineers can take. I teach 2 of those on the collections library. One thing that I've learned as an instructor at Twitter is that it's absolutely critical to provide a very gentle on-ramp for engineers coming into Scala. A lot of the engineers I teach are not just new to Scala, a lot of them are fresh out of college, and this is possibly their first time ever writing professional software. So they're understandably scared and nervous and still finding their footing. So that my basic collections class, when I say basic, I mean it in its truest sense. My first exercise is how do you take the size of a collection? I start at that level of basic to help people find their footing and gain confidence, even though it's a very simple exercise, just to get them comfortable in the IDE, comfortable with the language, comfortable with the collections library. And we build up from there, and eventually we talk about streams and views and iterators and more complex concepts. And I would also say the other big lesson is that when you are teaching someone, it's important to stay hands on keyboard as much as possible. Lecturing someone about the collections library doesn't really get the point across so much as asking them to pull out a REPL, pull out an IDE, and giving them a task to accomplish. And those are the tactics that we've found are most effective, and all of our classes try to follow that lesson.
Cool, and obviously you said that Twitter has a team of 3 people that are dedicated full-time to that. I'm guessing a lot of people in this room don't have those kind of resources to dedicate to internal training. So is there anything that you've learned from your experience that somebody that doesn't have a dedicated training team could take into their companies?
That's a good question. I would say if you don't have the resources yourself, you can certainly hire them. There are plenty of people here that you can hire to come in and teach these courses for you if you don't have the resources to staff them yourself. And I think that kind of hands-on personal instruction, in my mind, helps bring people up to speed faster than any other resource. I'll mention briefly 2 other tactics that we've started experimenting with. One is we're now buying a copy of Scala for the Impatient for everyone who joins my department, which is out in Colorado. So when they sign their offer letter, we're sending them an ebook copy of that. Another that we're experimenting with is we're developing an onboarding program that lasts over a quarter. So we have a program that starts in their first week, but it's very intensive. We're now experimenting with 30 hours of courses spread over a new hire's first 3 months at Twitter to give them a gentler on-ramp that's a little more spaced out and that they're undertaking along with their day-to-day work on real production software, which I think helps them better understand how the concepts they're learning about Scala are applied in our real code base.
Awesome. The next question is for Heather and Martin. You use Scala to teach in a very academic setting, and so I'm wondering what it's like to teach students specifically with Scala and how that might differ from teaching other traditionally used languages in academia.
So what do you mean with languages traditionally used in academia? So
I just don't think that you see Scala in a lot of universities.
okay,
So
yeah.
there's not as much curriculum out there that exists.
Right. So my experience is only teaching Scala in second year after they had a year of Java.
Okay.
So basically, my job is to say, well, forget most of what you learned about Java and essentially start from scratch, recursion, immutable data, and so on. And that works actually pretty well. Usually students would resist because they would say, well, it's academic only. And there I can just tell them, well, look at all the jobs out there and the salaries and things like that. So that cures them. And they take an interest. What the academic setting is much more than the industrial setting, I guess, is that you try to really have minimal examples, super, super simple. You might say academic examples, because once you start a real API out there, it's probably already so, essentially, there's all this complexity in there which has to do with dealing with real-world situations, which detracts, if you do it in a classroom setting, it detracts the students. So we really try to sort of find something as simple as possible and then drive the point home to teach it. The most important part really is to find good examples there.
Do you have an example of your examples?
Sorry?
Do you have an example of your examples?
For the first MOOC that we teach, and the first course that we teach that's heavily inspired by the Abelson-Sussman book, Structure and Interpretation of Computer Programs, a classic book. So in the second week, we have this example with essentially fixed points, where the example is computing the square roots and doing so with higher order functions, and then it goes all the way to fixed points, and then it goes to representing sets as functions and things like that. And that worked reasonably well at EPFL, and when we translated it to the world at large, people revolted, and they said, well, this is way too mathematical, who's interested in this sort of stuff? And then Heather actually put a face on it, and she actually covered it in tweets. So she said, essentially, the sets are now sets about tweets and Twitter things, and that made it much more acceptable. So you have to see both sides, but I guess with university students, you can be a bit harsher on them. Yeah.
I think that's a good transition to talk about some of the things that you've done, Heather, at Northeastern.
Yeah, so I mean, so the context that I have sort of teaching in Scala is at EPFL. I've TA'd for the functional programming course, so the second year students that he's talking about, I was in on that, and then I taught this course called, what was it, concurrency and parallelism, I guess. And so that's, I think, a third year student. They had already taken this functional programming in Scala class, so they already knew Scala, and then they had to start solving some, okay, here, race conditions, have fun. And then at Northeastern, I picked up senior students that are, in their last semester, or maybe junior students. So they have about a year to go before they would be graduating, and a lot of them had already gone off to industry and had some work experience. They've taken maybe 2 semesters of like internships or whatever. So they also had sort of, they'd learned functional programming in the context of like Racket, which is kind of a scheme programming language, right? So they know some functional programming. Then they use Python or Java or something else in some company that they went and worked with. So they weren't completely, brand new to it. But these are the groups of people plus the Scala Bridge folks, the women who'd like to learn how to program. These are the different sort of groups that I've taught, and I have to say that I noticed kind of the same thing, regardless of the senior level students at Northeastern who had learned Scheme, or the students at EPFL. In both cases, where I've taught these different groups of students with more and with less experience, the same thing helps, where you take something that is perhaps cute and academic, you keep it still cute and academic so that they can focus on sort of like the gist of the problem that they're trying to solve, but you give them a way to connect to it. So, the tweets thing was an example. Like, if I just give you a bunch of math, perhaps you can't really get personal with that. But if I can give you like some saucy problem where you're like trying to say like, oh yeah, Android is better than iOS or something, they get more into it. And so I've found, especially when I'm teaching, for example, these students where I would, at Northeastern, the goal was to kind of get them into using Spark and then throw them into AWS and be like, have fun. And I have to teach them Scala first. I teach them Scala in a week. Like I said, they already have programming experience, but I start with those cute examples. I give them lots of hands-on, usually things that I pulled from EPFL, what we taught our undergraduates there, or other examples that I found or came up with over the years. And it's sort of like an intensive Scala bootcamp, but still those cute little examples that have a face on them. And then I basically try to relate that to the APIs in Spark. So lots of collections-heavy stuff. Things that, okay, you've seen list comprehensions, right? Okay, well, for comprehensions, that's what we have in Scala, and, this is what they look like. And actually, hey, when you have Spark, it's the same kind of thing. You can use higher order functions and all of that. It's the same general concept, so but distributed. So I actually take the same approach, even if I'm teaching people that are even more advanced or have already had some functional programming experience in the past as well. So for me, even translating some other language into Scala, it's keep the examples simple enough, but not too simple, and then give them a way to relate to it, because you don't want the problem too abstract. It makes it less accessible for somebody who maybe is not a math whiz, for example, or didn't grow up loving math.
As a follow-up to that, I mean, Martin, you are, I think it's fair to say, intimately familiar with the Scala language. You've been working with it for so long. It's your, brainchild. How do you teach someone at a very beginner level without getting too deep into all the things that you obviously know?
So I don't really have a lot of experience with non-programmers, and that's something that I think would think is really interesting if we could essentially how non-programmers would react to Scala as a first language. I know there's some courses out there, and I would be very interested to find out more of what they do and the techniques. So my experience is really only two essentially traditional programmers, typically people knowing Java or Python or something like that, and then what to teach them. And I think that what I do is really not use a lot of the features, just really do the basics, do recursion and pattern matching, do collections, and then stop. And so not be too ambitious. So I actually regret that I never taught an advanced Scala course, and I would very much love to do that. So maybe next year or something. But I guess when Scala 3 comes out, then that's what I'm going to do, because that's all the shiny new features. They need to be taught, and then I'll jump into it.
Yeah.
And go overboard.
Heather?
Can I share an anecdotal story from doing a Scala bridge?
Yes.
It's one of my favorite little stories. Okay, it's not super long, I swear. So I was organizing a Scala bridge in Switzerland, and I knew somebody in Switzerland. She came to me, she said, I have two nieces. They don't even have a computer. I'd like to teach them how to program. It would be really cool. Like she's actually a Scala developer, and she's like, I would like my nieces to learn this. They're 16. I'm not sure they can do it. Actually, they've only ever used an iPad. So I'm not sure if they're even going to understand, compilers, right? Because I have a file, I put it into a compiler, get a different kind of file out. They're just like using iPads. Everything is synced in the cloud. Like they're not going to understand this whole process. We're so scared. And then, okay, well, it's all right. We'll just handhold them a little bit more. Don't worry. And at the Scala Bridge that I organized, there were a lot of women who had experience with JavaScript, some people who did a lot of maybe they did some sort of processing of stuff in spreadsheets and whatnot, so they had maybe some experience in another language or some kind of spreadsheet sort of experience, and some men came also were JavaScript developers. And if anybody has looked at the Scala Bridge curriculum, it's Creative Scala. It's by Noel Welsh, right? I don't know if he's here, but I highly recommend it. It's super cool. And what's really nice about this is that it teaches these functional concepts, but it does it in a visual way. So you don't, again, it's like I don't have to introduce programming to you by making you make a calculator. I can teach programming to you by making you draw a picture, and that's a super accessible way to teach people who have no experience in programming. And so these two teenage girls show up, and it turned out that the workshop is like, I don't know, 8 or 9 hours or something. It's pretty long. And they just blew through the whole thing in 4 hours. It was so easy for them, and all these adult men who had been using JavaScript for years were stuck in the first 2 or 3 exercises because they were really caught up on mutability. Like, well, how do I change that thing? I just assigned it, but I want to update it. I'm like, no, that's not the point. And these girls were like, why would you do that? You just transform it. Why? I don't understand. They were asking them why they would do that, and they were like amazing, and we were all just like, what do we do? And then we taught them Git because they were bored, and the whole thing wasn't over yet. So I don't want to say that functional programming is the right way, but it turned out to be really intuitive in a way that I never expected, especially for 16-year-old girls who didn't know what a file was, and that for them to get through the whole curriculum in half the time. It just shows that I think that I don't know, to somebody with a complete empty slate, teaching them in a different way. It might not be that hard, actually. They were answering to these other people who had more experience, explaining things to them. Well, that means you can't mess it up later. I didn't tell them that. They just inferred that, and that's great. It was more intuitive, right? So this was a really cool experience, and I wouldn't have done it. I wouldn't have had this experience unless we did the Scala Bridge thing, where we had these complete beginners, and we're just like, okay, can you digest this? I don't know. This is an experiment, and it was really surprising.
Excellent. I love that story. Maciek, you did some research on what motivates people to learn Scala. Can you share your findings, and was there anything in there that surprised you?
Yeah, sure. The survey was made for more experienced programmers that already are in the work field, and they work in Java, Python. I think these were the two most popular languages of people who answered my questions. And I wanted to know what areas of IT they work in, what are important for them if they want to learn another language, not especially Scala, but well, of course it was somehow pointed out. Then what is interesting for them, and what would motivate them to learn this new language, and also like what are their methods of learning, because of course at some point you don't rely on just your past university, you just have to find your own way to learn new things. So two things that were quite interesting for me was that creating that survey, I had some kind of a hidden agenda that I wanted to find an answer if we're talking a lot about functional programming, but I wanted to find out if this is only our hype, like we are so interested in functional programming, but everyone else is like meh. And no, I see that many people who are thinking about learning another language actually are interested in functional programming. But I think, okay, so maybe I'll just talk more about it and then I'll talk about the other point. But it seems that Scala, there's the stereotype that we have this quite steep learning curve, and if someone wants to learn Scala and she's ambitious and wants to learn functional programming together with Scala, then this learning curve becomes even steeper. So it's important not to scare these people away. Like if we have this sort of like an intermediate gap that we have some basic examples at the beginning, some kind of what to do with collections, how to do a flat map, and then it goes up, and then we have some very abstract, very monadic discussions about very specific stuff and very specific libraries. And there's hardly, well, maybe there is something in between, but it's much less material. So in order to not to waste all that interest and all that motivations, I think we should, as a community, invest more time in creating some materials, something like a functional programming 101, or something like, I don't know, functional programming for models. So that's one point. And another one is that how they learn. If you already did some projects in other languages, then it seems that most of people are very keen to learn a new language, not by going to those all those examples, but by actually writing something by themselves, like starting a small project. So that was interesting. I thought that I'm one of the, I don't know, a few people who do that. But yeah, so that was the most, the answer that people chose the most, and also that they like articles and tutorials in the written form, and much fewer people answered that they like the video tutorials or courses on Coursera and so on.
Excellent. I'm going to cut you off there.
Okay.
Because your research is available, so we can share that online.
Yeah, I put it on Twitter. You can, with hashtag Scala Days, you can check it.
Yeah, so we'll definitely share that after this panel. There's some really interesting results in there. Probably time for one more question before we hand it over to the audience. So what's your approach to introducing functional programming concepts, things like that get a little buzzwordy and a little jargony, things like monoids and functors? When do you introduce them, if at all, and what motivates you to introduce them? Yeah?
I can answer the part about monoids and semi-groups, because those are the two concepts we introduced to data engineers. They are most relevant to in the context of MapReduce, and we introduce it in a more friendly way. So we're doing word counting, like everybody's seen like a Spark word count or whatever. So starting with that, and then we can visualize how they work out on a bunch of machines, thousands of them, and then we can use some more approachable example, like the one that we use in the class as a juicer. So, mappers making juicers, send them over to the reducers, keep, mixing them, and then we gradually introduce the concept of associative and commutative operations, and then it turns out just, being the monoid and semi-groups that we were talking about. And I think it really depends on the context of your application. In the data world, in my experience, those are the only two category theory concepts data engineer really need to know, and most of the other ones are not as relevant, like the things we talk about, everyone's talking about free monads or tagless final. I just haven't really found an application for application user, maybe for library user to some extent, but for application user, not as much.
Everybody knows my opinion on free monads. Ryan, do you have any thoughts on this?
Sure. This is one thing I think the Scala ecosystem has done well is introducing monadic concepts like option or future without actually calling them monads, at least in the early days. I think that is probably Scala's greatest gift to functional programming, is not calling those things by their category theory names. Conversely, something that I think we have fallen down on is when someone first tries to combine options and futures into for comprehension and they land on a Stack Overflow question, the answer to which is monad transformers. And so when I am trying to help someone who's in this situation, I will generally guide them away from the more functional answer. And I generally, in my courses, I never call things monoids or monads. I just, introducing someone to these concepts through examples, as Heather said, examples first, jargon second, I think is absolutely the only way to do it.
Excellent. Yep, Martin?
I just want to make a plea here, which is I think we are in danger of actually misusing the name functional programming. So functional programming is programming with functions, and I'm completely willing to accept that these are mathematical functions, so without side effects, and that's what it is. Functional programming is not necessarily to essentially use monads or monad transformers or Kleisli or the whole categorical thing. That's something different. That you can call it categorical programming or maybe fundamentalist functional programming. But functional programming is much, much larger than that. So otherwise, I mean,
Hashtag fundamentalist functional programming. Get it trending, people.
if you say functional programming is that, then ML, Camel, Lisp, they're all not functional languages because they use none of that. And I think that's incredibly exclusive, and we shouldn't fall into this trap to essentially reserve functional programming for essentially programming with essentially higher-kinded abstractions and design patterns. These things definitely have their place. So I see them as essentially when you run your head 10 times against future and option and convert it to option or future or more complicated things like that, then you start to see patterns and you say, well, sometimes these libraries and type classes, they actually can help you there. And, but for teaching, it's a disaster to put that first. So it's just like teaching design patterns as an intro to object-oriented programming. People will get their head full with jargon before they see essentially simple cases. And they will essentially try to apply very complicated and very powerful things because they think that's the answer for essentially the simple problem they're trying to solve without them, in the end, understanding anything. So I think it's very, very important to say, well, these things, we have to introduce them, but we have to introduce them late when we talk about, essentially about large systems and the equivalent of design patterns.
And I think it's also convenient to, you know, like, as you said, okay, option and future and these kinds of things, you know, just use these things for a little while. It's fine, don't worry about it. And then down the line, we can start learning why these things are monadic. What does that even mean? So, I mean, you know, this is something very intuitive that you've been using for a long time. And by the way, this is how this thing may or may not be a monad, right? Oh, you didn't know what that was? Well, that's why we call them monadic, whatever. So I mean, you know, it's something where after I think people have had enough examples, they see that there's a common shape, then you can say, well, that's what this is called actually. You've been using it all this time, no big deal. You know, and so if you ever want to do something more generic or general or whatever, you know, look in that direction, but you know, you actually got it the whole time. You've been using it. You've been using this for a while now. And this is kind of goes with the, hey, examples first, and then we can learn hilarious terminology later.
Excellent. I think we're going to open it up to audience questions. So if anybody has any questions for the panel, we've got a microphone that's coming around. We can wait for the microphone. There's a question right over here.
Hi. 5 years back, I started with Scala with Scala Impatient book. I didn't understand completely what they are saying. So after that Coursera course really helped me a lot to understand Scala. Now my question is, now I'm in a situation same like 5 years back. What is a type theory? And I want to understand type theory a lot. But now I'm looking for help in Coursera course like type theory and all those stuff. Is there any possibility to arrange a type theory course in Coursera?
Well, that's not, yeah, so there's not really a single resource that you could say that's the definitive resource. Somebody wants to know more about types, then there's the red book, the types and programming languages, which is sort of a red brick wall book. Everybody in types knows that. And to say, well, to essentially study type theory in isolation, I would say, yeah, read that book. And we have a course, I teach a course on master's level that does that, that uses that book as a textbook. In a more Scala-specific context, I think there's a need for that, for sort of a definitive resource to teach these things, but we don't have it yet, yeah. Also, I guess one reason for not having it yet is that I believe actually things are still in flux, that the type theoretic concepts out there move relatively slowly, but essentially the things we do with them, essentially what kind of type theoretic constructions to use for what feature, that is still very much in flux. So I think the situation in 2018 is not what it was in 2017, is not what it was the year before. So it's very hard, as long as things are moving so quickly, to actually freeze that and say, okay, we're going to teach that, because we're going to teach it for 10 years to come.
Any other questions? One in the corner over here.
Thank you. I think I have a few questions, but I start with the first one. You thought a lot about, other way. The biggest strength and weakness of Scala is I can do everything. I can do object-oriented, I can work functional. I think the big question is how to do it right. How to teach, where's the abstraction, which should be with side effects, which should be without side effects, how to cut this line. Mostly with people who already have object-oriented experience, but no functional experience.
So I guess my answer would be, as soon as you construct a difference between object-oriented and functional, you're already gone down the wrong path for Scala. So if you teach it, always teach it that it's both, and that a function in Scala is an object. So if you say it's object-oriented or functional, then I would essentially say, well, no, actually not. It's both, and we have to try to teach the synthesis of both. What we certainly should be careful about is to say, let's say, aspects of object-oriented programming like side effects, which is actually, for me, not an aspect of object-oriented programming. That's just imperative programming plus object-oriented programming. So there, of course, you say, well, in our teaching, we typically say, well, we wait with that. So typically 7-8 weeks. In week 9, we introduce variables, and we tell them essentially both what they can do and what the dangers are for fusing them. And essentially, you want to get at a situation where you can say, well, these things have their place, typically high performance, caching, but they have to be carefully contained. So for me, the most interesting code is actually code that is completely functional at the outside, referentially transparent, and pulls all the tricks with like variables and side effects, typically for caches on the inside, to get really fast performance. That's where sort of the kind of code I most like to read and see. That's personally most interesting for me. Of course, if you don't need to do that because you don't have a performance problem, then don't do it. Just be purely functional. If you have to do it, then do it in the caches, but be purely functional at the outside would be this idea. So for me, then, essentially this idea that good Scala is both objects, because objects are the modules, and functions for the behavior, and essentially a careful amount of mutable state for essentially keeping the thing performant or reactive, or what you need to do there is sort of the right balance. But it means that I would introduce state last, because essentially premature optimization is the source of all evil.
And just to weigh in on that, and of course I'm biased, but I kind of, the functional programming in Scala course, the one that became a MOOC, and that's a course at EPFL, it teaches object-oriented things. We teach delegation and all kinds of things, state and whatever in that course. It's called functional programming in Scala, but there's things that one who would teach an object-oriented programming course would also teach actually in that course. So I guess the point is that this is, obviously this is your course design, but it still sticks with this idea of, well, they're not two separate things, they're one thing. And you have these concepts kind of in this one course like merged.
Imagine a situation, there is a team, established team that does Scala development, and a new developer joins who has like some JVM background, so let's say Java background, but no Scala. And when he starts to see how things are for Scala, like when he starts to see the tooling and the performance like of SBT, of compilation, etc., and he says, why not Kotlin, for example? Yeah? So tooling is arguably better, compilation time is good. What to answer to him?
I mean, maybe somebody that works in industry can answer this. I'm sure you get a lot of varied backgrounds in the teams that are joining.
So Twitter's in a little bit of a unique position. We have so much of our own tooling that we've built around Scala. Like Pants, we don't use SBT, we use Pants, which is a homegrown build tool. It is open sourced for those who want to use it. But we certainly have our share of people who join and run up against how long things take. Not just with Scala, for instance, we're in a mono repo, it's millions and millions of lines of code. Pulling new branches can take long enough for a coffee break. So ultimately, I don't know if there's a great way to address that beyond the fact that they'll eventually get used to it. That's not a satisfying answer, but in my experience, as people see the benefits of the tooling we have, the use of Scala, the objections sort of fall away because they start to see the benefits and what we get out of it. So I think that's the key is make sure you should make sure that you actually are getting the payoff from using these tools. And if you're not, then perhaps that's a different issue. But if you are getting the payoff, I think your engineers will come around to that same realization as they progress in your company.
So, hello. I'd like to share my experience on this topic. So, you already mentioned like the benefits that you should experience them. So, my experience is actually that if you come from something like Maven, the tool design is less principled in some ways, and I think my experience with other tools is that it actually breaks in a lot of fundamental ways, which makes the development cycle slower. So I think you should focus on the fact that SBT, for instance, has a very nice watch mode, which actually gives you direct feedback when you change a line of code, because incremental compilation is much better in Scala than it is in, for instance, Java. So I had a lot of questions about like why is Scala so slow, and then I show examples of like, no, it's way faster actually than doing a normal, regular Java-like cycle. So I think this experience of people thinking it's slow is like FUD. It's really that some people are very vocal and say it's slow, and then people mentally experience the slowness but don't see the speed that are in other places.
Yeah, compiler speed is a very complicated thing. So the first thing mistake that many people make is they just start a cold compiler and says, well, it takes 5 seconds to compile Hello World or something like that, and says that's actually not compiler speed. That's just startup, scanning the class paths and things like that. And it's true that Java C has heavily optimized that, and we could do as well, but it would take a lot of resources. And you generally just say, just use tilde compile in SBT or an incremental compiler, and then it's really fast. The second observation is it really depends a lot on your code. So for the code I write in the Dotty compiler myself, I measured that. I get on average about 3,000 lines a second on my MacBook, which is fast enough for me. With the incremental compilation, it means that I rarely wait more than 1 or 2 seconds, and which means I don't wait at all. It's just when it's done, when I look at the result, it's done, and I basically never wait for the compiler. But of course, that means that you can have both a lot more code, like Twitter, and then it does matter, even at maybe 3,000 lines a second, you still take a long time compiling. Or you might have code that compiles slower because it uses a lot more high-level, higher level, type level, implicit searches, other complicated things. And
all right, I don't want to derail us too much. This is the education panel. We can talk about compilation speed
right,
tomorrow
yeah. Okay,
at the ending panel. And we have time for one more question. Yes, Adrian and Martin will be on stage at the end of the day tomorrow, so we can ask them all the questions about why the Scala compiler is slow or perceived to be slow.
Yeah, I think when beginners move, or let's say people who are beginner with Scala but move from another language and want to do Scala right, so you have to use avoid the var and these things. I think it's really a challenge that at some point of time you suddenly can't program anymore because everything doesn't work. The for loop is not there like you are used to. You can't change anything, and you have to really start from scratch. And I think that's a challenge to get across this moment.
Yeah, that's right. It's a chasm that you have to traverse. Yeah.
Okay, one more question. Yeah, right there.
My own experience when I started with Scala was trying to read the language documentations, which actually read more like white papers. Each time I wanted to see how something worked, pulled in quite several things, tried to explain everything I wasn't interested in at that point. And yeah, I think that also is a hurdle to take at some point. That was it.
So I don't know when you picked it up, but the cool thing is that last July or so, there was a big effort to rewrite the whole tour of Scala thingy. I don't know, did you look at it? Is that when you looked at it? Okay, anyway, I don't know if this helps, but we asked somebody who was a complete beginner, basically, to rewrite it, because when you're already used to these concepts, maybe you don't teach it in the most intuitive way. So we had somebody who was just learning say, okay, if somebody's going to teach this to you, how would you do it? And I think I'm not going to say it's perfect, I mean, you know, but I think that he made it far less ridiculous than it used to be.
Also, if you look at actually the .e documentation, so we have essentially a reference which has one section for each of the things that has changed or got dropped or got added, then I hope you have a more positive experience this time around.
I'd like to add on what Heather said about having a complete beginner write the documentation. In a more general sense, especially when you're hiring, having the most recent hire teach the next hire means that it's always the person for whom it's freshest in their mind. I think that tactic can really help a lot, because when you have your most senior person try to teach the new hire and they've been there for several years, it's difficult to recultivate that beginner's mindset. And also, if you have the most recent hire teach the next hire, you're spreading out the workload, it's fresh in their mind, and they still have the beginner's mindset. They don't have to go dig it back out the way someone who's been there for several years might.
Excellent. That's about all the time we have. I want to thank all of our panelists for their time today. Thank all of you for coming today, and thank you for listening.
Thank you.
Okay, thanks.